Hello everyone, this is a new video where I'll be discussing previous year questions, physics question paper of CBSE exam of 12th class, and it will be really interesting video because we'll be discussing all the MCQs and assessment reason question, 1 mark questions, and if there are numericals also we'll discuss. Okay, so I would urge you to also um, solve along with me so that it will be really helpful. Otherwise, there is no point. Okay, yeah. So let's start one by one. We'll do the questions. All right. So this is the first question. A thin plastic rod is bent into a circular ring of radius r. Okay, it is uniformly charged with charge density lambda. The magnitude of the electric field at its center is. So this is the question. All right. So okay, I think I need another page. Anyway, okay. See, thin plastic rod is bent into a circular ring of radius r. Okay, thin plastic rod. Suppose this was a plastic rod, it is bent into this circular ring. Okay, it is uniformly charged with charge density lambda. So this one lambda was the charge density of this one. Okay, and now it is the charge density. Okay, now it is distributed over a circular ring. The magnitude of the electric field at its center. Okay, so the magnitude of electric field at its center. Okay, let's see. So this was lambda. All right. So lambda was the charge density um, for the plastic rod, right? So charge density is what we know. Charge density is lambda is equal to q by. This is which kind of charge density? This is a linear charge density lambda q by L, right? Q by L. Okay. So now this L has become is converted into a circular ring. So L has like now L is equal to 2 pi r, correct? L is equal to 2 pi r. Okay. So R is equal to what? L by 2 pi. R is equal to L by 2 pi. And now the what is the magnitude of electric field at its center? Okay, at its center. Okay. So the thing about it is, see, suppose we enclose this. Okay. All first of all the charges will be on the surface of the circular ring, right? All the whatever charge positive and negative, the charges will be on the surface of the circular ring. So there will be no charge at the center. So the electric field will be outward and outside the circle. So there will be no electric field inside. So at the center there will be no electric field. We can also prove it like Gauss law. E dot ds E dot ds is equal to q by epsilon naught, right? Q enclosed. So if I draw a circle around the center where we need to find the electric field, there the q enclosed is zero because all the q are on the surface. Okay. So this is zero. So electric field will be zero. Okay. So the answer will be zero. Okay. So this is a explanation for it. Yeah. All right. So next question, the capacitors, 10 capacitors, each of capacitance 1 microfarad. Okay, 10 capacitors, each of capacitance 1 microfarad are connected in parallel. So 10 capacitors are there. Okay, there are 10 capacitors, and they are connected in parallel to a source of 100 volt. Okay, there is a source of voltage 100 volt. Total energy stored in the system. So very simple question again. You just what you need to do is simply calculate the equivalent capacitance here in the system as they're in parallel. So capacitance in parallel will simply be added. So 10 capacitors of 1 microfarad. So it will be 10 microfarad, right? And the total energy stored. So voltage is this. Energy formula is U is equal to what? Half CV square. Okay, U is equal to half CV square. So half into C. C is your 10 microfarad. 10 into 10 to the minus 6 micro is 10 to the minus 6 into V square. That is 100 square. That is 10 to the power 4. Yeah, because this is 10 to the power 2, 4. So this becomes 5 into 10 to the power minus 2, isn't it? 10 to the power 4 into 10 to the minus 6, 10 to the minus 2. So 5 into 10 to the minus 2 joules. Right? 5 into 10 to the minus 2 joules. So we can also write it. Yeah, this is the correct answer. Option D. Option D is the correct answer. All right. Yeah. Okay, let's move to the next question. Consider the circuit shown in the figure Potential difference between points A and B. Okay, potential difference between the points A and B will be what? So simple, very simple question again. See, if two batteries are connected like this, positive end to positive end, negative end to negative end, so the potential difference here will simply be subtracted. Okay, so 12 minus 6 is equal to 6 volts. So the answer will be 6 volt. Very easy question again. Okay, if they are opposite connected, they would have been added. Okay, next, how why they subtracted? If we apply Kirchhoff's law also, you would have started from 12 minus something minus 6, right? Because current is going from positive into negative, so eventually it is 12 minus 6, right? Yeah. Next question. A loop carrying current I clockwise is placed in XY plane. Okay. There is a loop carrying current I clockwise in XY plane, clockwise like this. So this is X, this is Y. Clockwise in XY plane. In uniform magnet will be directed along Z axis. So the magnetic field is along Z axis. And the current is along like clockwise direction. The tendency of the loop will be, okay. The tendency of the loop will be. So this is the question. Okay. So how to solve this one? How to solve this one? Okay, the current is like this. So the magnetic field. Okay. So the magnetic field will be along, because this is clockwise. So if we use the right hand thumb rule, magnetic field will be like this. Okay, correct. Magnetic field will be like this, isn't it? And also the external magnetic field is also like this. Okay, so what will be the tendency of the loop? Okay, you see here what will happen is uh, mm, suppose the magnetic field was towards like going inside, going inward. Okay, and the loop will have anti-clockwise current, so it would have contracted. So this one will also contract. Okay, here the loop will here the loop will contract. Okay, so the answer will be shrink. Contract means shrink. This will not happen. Move along x, because xy plane, the loop is in the along xy plane. The magnetic field is along z axis. So and this magnetic field is also along z axis. So the whole thing will shrink. Okay, it will shrink down. All right. Yeah. The next question. A 10 centimeter long wire lies along y axis. 10 centimeter long wire is along y axis. Uh, Carries a current of 1 ampere positive y direction. Magnetic field is given. Force on the wire. Okay, try this question. Very easy question. Very easy question. Try. Everything is given. See, 10 centimeter long wire. So L is 10 centimeter. Carries the current of 1 ampere. So I is 1 ampere in positive y direction. Okay. So current is along positive y direction. So we can say L is positive y direction. That's J cap. Okay. It's because this is a current element. It's taken as ideal. Current doesn't have any vector sign. So our dl is the vector quantity. So the direction of current will be taken as the direction of dl vector. Okay. J vector. Magnetic field. V is given as 5 j cap minus 8 k cap. Okay. Millitesla. You can take it out if you are confused. Force on the wire, very simple. Force is equal to F is equal to I L cross B. Correct? F is equal to I L cross B. So I is your 1 ampere into L cross B. So cross product will be there. 10 J cap, 10 into 10 to the minus 2 J cap cross. This is 5 J cap minus 8 K cap, and this is 10 to the minus 3 milli. Na? Okay, the thing is here j cap cross j cap is 0 because same cross product j cross j is 0, I cross j is 0. So j cross k will only be there. So I cap and 10 to the minus 1 into this is minus 8, 10 to the minus. Okay, the answer will be minus 8. Answer will be what? Minus 8 into 10 to the power. Just a second. Minus 8 into 10 to the power minus 3, minus 5, minus 4. Okay, yes, minus 4, and this is Newton. So 8 into 10 to the minus 4. So we can write it as minus 0.8 millinewton, correct? 10 to the minus 3, 10 to the minus 10 to the 1. So this option B is the correct answer. Okay, here's a question again. Alright, okay, I hope understood. Question number 6. Galvanometer of resistance G ohm is converted into an ammeter of range 0 to I ampere. This is I or 1. Okay, whatever. I think this is 1 ampere. Okay, this is not I. This is, I think, 1. This is, I think, 1. It should be 1 ampere. I ampere doesn't mean it. If the current through the galvanometer is 0.1% of I ampere. Okay, suppose this is I ampere. Okay. The resistance of the ammeter is. Okay. So this is again a very easy question. Ammeter is connected in what? In parallel. Right. Ammeter is connected in parallel. Like the resistance connected parallel. So see here, galvanometer G is converted to ammeter of range 0 to I ampere. If the current through the galvanometer is the resistance of the ammeter. Okay. So here, the thing is, this whole system is called your ammeter, right? Yeah. This is connected in series with the circuit, but this resistance is connected in parallel. So this is the current. Okay. So current is gets divided in two parts. First is suppose this is I, this is Ig. Okay. So IR is equal to Ig into G. Correct. Yeah. Or you can say I minus Ig. I minus Ig. Sorry. R is equal to IgG. So the resistance of the ammeter R is equal to uh, G ohm. G ohm is fixed. R is not given. No? Current is 0 to I. So current is I actually. Yeah. I mean Ig. Yeah. Current to the galvanometer is 0.1. Okay. Current to galvanometer. Ig is equal to 0.1% of I. Okay. So this is the one that we need to use. So this is kind of a 1 by, I by 1000. Correct. So in place of Ig, let's put I by 1000. So I minus I by 1000 whole into R is equal to I by 1000 into G. Got it? Because Ig is equal to 0.1%, 0.1 by 100 into I. Okay, so if we subtract it, this will be 999 I by 1000. R is equal to I by 1000 G. Okay, So I cancel out, 1000 also cancel out. So R is equal to G by 999. That's the answer. Okay, got it? You need to be first clear what is an ammeter. Okay, in an ammeter, inside an ammeter, is connected in series, but in the inner structure of ammeter is what? There is a galvanometer and there is a parallel resistance with the galvanometer. Okay, this is your ammeter structure, inside structures. This is I, this is Ig suppose. So this would be what? I minus Ig. So I wrote the equation as this potential difference across this should be equal to potential difference across this because they're parallel connection. So I minus Ig whole into R is equal to Ig into G. Correct. So this is the equation I wrote, and Ig is what? 0.1% of I ampere. So that's why I wrote Ig is equal to what? Ig is equal to what? 0.1%, 0.1 by 100 of I. So from there, I just put it and did the question. Right? I hope understood. Next question. The reactance. Okay, let me erase this a bit. Please read the question, next question, and try to solve. Yeah. Reactance of a capacitor, capacitance C connected to a AC source of frequency omega is X. So, reactance of a XC is given as X. If the capacitance of the capacitor is doubled, okay, capacitance of the capacitor is doubled. So Xc we know is what? 1 by omega c, correct? Okay. Capacitance of the capacitor is doubled. So C is doubled now. So C dash is equal to suppose 2C. C is doubled. The frequency of the source is tripled. Frequency. So omega is your angular frequency. So omega is equal to 2 pi f, correct? So if frequency is doubled, so tripled, so omega will also be tripled. So omega dash is equal to 2, 3 omega, correct? So xc dash will become 1 by c dash omega dash. So that will be 1 by 2c into 3 omega. So 1 by 6 omega c. So 1 by omega c is your xc. So this one thing will become xc by 6, correct? So the answer will be xc is your x, so x by 6. Got it? Very easy question. I'm doing this really fast because these are easy questions, and I hope you can solve them. Okay, if I okay, suppose if you didn't understand, Xc is what? 1 by omega c. This is reactance of a capacitor. Here it is said that capacitance is doubled. So C is doubled. That means C dash. Suppose the next capacitor. This is 2C doubled because the original is C, so this will be 2C. And frequency is tripled. So frequency is F, but omega is equal to 2 pi f. So if f is tripled, omega is also tripled directly proportional. So omega dash is equal to 3 omega. So xc dash will be 1 by omega dash c dash. So 1 by 2c into 3 omega. So that will be 1 by 6 omega c, correct? So 1 by omega c is what? Xc. So xc by 6, correct? Xc by 6. Xc is given as x. So x by 6 is the correct answer. Alright. Okay. Next question, question number 8. Let me erase this. Four regions I 1, 2, 3, 4 electric fields are described as this. Displacement current will exist in the region. Okay, displacement current will exist in the region 1. First of all, to do this question, we need to know what is displacement current. Displacement current is simply IT is equal to phi epsilon naught d phi by dt. Correct? Yeah. So this is your displacement current. Alright. So the thing is, uh, mm, so we this see. Okay. For what is phi e? Phi is equal to E dot ds. Correct. Electric flux E dot ds. Alright. So the thing is, mm, electric field is inside this one. Suppose area is constant. So this becomes epsilon naught A dE by dt. Correct. So the thing is, think about displacement current is what is the definition of displacement? Displacement current occurs because of because of change in electric field. That is the definition of displacement current. So if there is a change in electric field with respect to time, there will be displacement current. So we have to see which function here of electric field is a function of time. Which of the function is a function of time. So see in which term there is time. The first term, right? If we take the derivative d by dt of this one, we will get what? E naught cos kz minus omega t into minus omega. Okay, because of this one. But this term, if we take the derivative, we'll get 0 because E naught is a constant 0. This is 0 because there is no t term. Derivative is with respect to t, but there is no t term. Here also 0. So these three terms we are not getting the displacement current. We are getting ID as 0. Only this term we are getting ID as some value, that is E naught cos kj minus omega minus omega. Okay. So the displacement current will exist in the region 1. Yeah. Yeah. Next question. The transition of electron that gives rise to the formation of the second spectral line of the Balmer series in the spectrum of hydrogen. Second spectral line in the Balmer. Balmer is first of all, what is Balmer? Balmer means n is equal to 2, n1 is equal to 2. Okay, alright, and others are coming from here. So second line, this is the first line. First line means n2 is equal to 3. Second line means this one. Second line means n2 should be equal to 4. This is from 4 to 2. 4 to 2 is the second line in the Wagner series. Simple. Okay. So 2 and 4. Okay. N final is 2. That means the final you can say final also. Ni is equal to 4. Anything you can say. Okay. Yeah. G is doped with arsenic due to doping. Okay. G is arsenic. Arsenic is a pentavalent impurity. So what will happen? Pentavalent means electron will increase, so number of conduction electron increases. Okay, increases. So sorry, increases now. Increases. Two beams, A and B. With A, please try to do this one. Energy is given. Aluminum metallic surface. Work function. This ratio maximum speed of electrons emitted due to that of this. See, first of all, we need to know the photon energy is given. Then we need to know the Einstein equation, which is half mv max square is equal to h nu minus h nu naught. H nu naught is your W naught or function. So h nu is given here 3.3 minus W naught is given 2.3. So for the first one, for the A, this becomes 1 electron volt. So half mv max square is equal to 1 electron volt. Okay. Now, second one is 11.3 minus 2.3, which is your 9 electron volt. So half mv max square for B is equal to 9 electron. This is for A. So just the ratio, we need to take the ratio. So V max square A divided by V max square B will be 1 by 9. Okay, because mass and mass will be cancelled out. So 1 by 9. Okay, 1 by 9. Answer will be D. Option D. Got it? Very easy question again. This is just simply the application of Einstein equation, photoelectric equation. Okay. Question number 12. Question number 12. The waves associated with the moving electron and moving proton have the same wavelength. Okay. So, first of all, what are the waves associated with some matter particles? They are called de Broglie waves, right? Matter particles called de Broglie waves. So, if the wavelength is lambda same, okay, so they have the same what? Okay, first of all, lambda is equal to h by p is equal to h by mv, correct? So, if they have the same wavelength, lambda, h is constant, so they will have the same moment. Okay, very simple question. If lambda is same, then your p will be same. Okay. So these were the MCQs, all right. MCQs from this chapter, all right. And sorry, from what do I say? From 2024. These are the MCQs from 2024. We'll separately do the numericals, all right. So first, I want to just finish all the MCQs, all right. Yeah, yeah. All the MCQs of previous training year questions. So these are the MCQs. Any doubt, you let me know in the comment section. Okay. Yeah. Okay. All right. All right. Okay. Thank you very much.